Hello, my name is Eric. I'm back in this final video in a series of videos on logic. So in the last three videos, we have looked at propositional logic, first order logic, second order logic. So now we are ready to tackle the incompleteness of the second order logic. But before I start, I just want to mention the background music that I have chosen for this particular video is coming from a Japanese jazz musician from the 1970s. I forgot his name. Either I forgot his name or I don't know how to pronounce his name. But in any case, I really like the jazz fusion music that the Japanese musicians put out in the 1970s. One thing I would say is that the Japanese musicians tend to have a very high level of technical ability. And they are not like their American counterparts. And the thing I'll say about the American jazz musicians is that they are usually very expressive, whereas the Japanese jazz musicians are a bit more reserved. But my God, their level of technical expertise is out of this world, And so now let's get back to this video. So in this video, we're going to show that the second order logic is incomplete. So that means even though second order logic is very nice and very well defined and things like that, but it still cannot escape the horror of Gödel's incompleteness theorem. And so let me bring up the second order logic incompleteness somewhere hidden here. Okay. So now we'll show that the second order logic system is actually incomplete. Okay, so before I start, I should say that whenever you say something is incomplete, whenever you say a system is incomplete, that means that there is always something in that system that cannot be proved by using the same stuff in that system. When you say you prove something, that means you can either say that that something is either true or false. But it turns out that you cannot say that anything in that particular system is true or false using only the stuff in that system. That's the meaning of incompleteness. And so now I'm going to show you the second order logic is actually incomplete in that sense. Okay, so that means in the second order logic system, there is always something in there that cannot be proved to be either true or false using only the stuff inside the second order logic system. Okay, so the first step is let's look at all the theorems in second order logic. And then now I will state it without any proof, without any validation of my statement. I will state that there are only countably many theorems in second order logic. So the operative word here, the key word here is countable. You can actually count them. There may be many, but you can still count them. Like for example, I can give you an example of a theorem in second order logic. One of the best theorems in second order logic is of course the prime factorization theorem. So the theorem says that every number, or I should say every integer, can be expressed as a product of a product of not just two, but the product of any number of prime numbers. Like for example, if I give you the number 6, it can be expressed as 2 times 3, because 2 and 3 are prime numbers. So that's the one of the many countably many theorems in second order logic. And then now I'm going to look at all the possible sentences that you can construct in second order logic. But it turns out that the number of valid sentences that you can construct in second order logic is actually uncountable. There are uncountably many possible sentences that you can construct in second order logic. Like for example, going back to the previous video, we said that there were 3 apples in a basket. So let me bring back that basket. And you remember this basket, and then so there were 3 apples, and then so we'll say that we were saying that there were 3 apples in this basket, and it's possible for me to say that because even though the concept of apple is a kind of a function, it's kind of a property, so apple is actually a property, and you cannot count the number of properties, in first order logic. You can only count them in a second order logic. So therefore, it's perfectly okay for me to say that there are 3 apples in this basket. Even though the apple is actually a property. And So we were saying that the 3 apples in this basket. It's one possible sentence that you can construct in second order logic. And so now let me bring back that the incompleteness back. I want to show you why second order logic is incomplete. Okay, so now there are countably many theorems that you can construct in second order logic, but there are uncountably many valid sentences that you can construct under second order logic. Yeah, and so therefore there must be some sentences in second order logic that cannot be proved, that can escape the grasp of all those countably many theorems. Yeah. So the sentences are uncountable, but the theorems are countable. So therefore, there must be some sentences that can escape the grasp of those countably many theorems. Yeah, and so therefore, voila, I have proved it. That means there is something in the second order logic system that cannot be proved using only the machinery in that system. Yeah. For example, there are some sentences. There are some possible valid sentences in second order logic that cannot be proved using only the countably many theorems in second order logic. And yeah, so I will leave it as an exercise to you. I mean, I actually don't know whether you can prove this sentence is true or not. Yeah, that means the sentence that there are 3 apples in the basket. Yeah, I don't actually know whether you can prove that it's actually true or not. Yeah. But as whether you can prove the sentence is true or not, it doesn't really matter. The thing that really matters is that there are uncountably many valid sentences in second order logic, but there are only countably many theorems in second order logic. So therefore, there must be some valid sentences in second order logic that can escape the grasp of the countably many theorems. Yeah. So that completes the second order, the incompleteness of second order logic. I find this kind of logical discussion fascinating. The more you delve into it, the more you learn about how people argue their way around things. Yeah. And so like I said, the objective of all these videos is not to teach you rigorous logical operations or logical discussions, but just to pique your interest. If some of you find it interesting, and then you move forward to learn more, then that would mean that my objective has already been satisfied. Yeah, and I'll be very very happy for you. Yeah, and yeah, so then that means that I will call it a day in this series of videos on logic, because I have to move on to the next series of videos on finance. Yeah, so as promised, I'm gonna pick up some really dirty tricks that people use in finance. Yeah. All right, so I'll see you in the next video. Bye.